This will be for the con exercise, exponential versus linear models. All right, so just some notes before we begin. I believe for all of these problems in this exercise, the only two answers will either be linear or exponential. So if you can eliminate one, then it's going to be the other one. Anyhow, if it's linear, you want to look at the y values. Okay, if you are adding or subtracting the same number each time, then it's going to be linear. Okay, if it's close enough, it's still going to be linear. So it doesn't have to be the exact same number each time, but it might be something that's just close enough. All right, and I think in most cases you'll know. And if you look at the graph, it will be a line. Okay, so it'll be something like that or something like that. It's just going to be a line. Now for exponential, again, you want to look at the y values. If you are multiplying or dividing the same number each time, it's going to be exponential. Also, if you're adding or subtracting the same percentage each time, it's going to be exponential. And that's because if you add or subtract the same percentage each time, that's going to be like multiplying or dividing. Just as an example, if you keep adding 100% to something, that's going to be the same as multiplying by 2. All right, if you start with 1 and add 100%, that's going to be 2. If you add 100%, that's going to be 4. Add 100%, that's going to be 8. So if you add the same percentage, it's really the same as multiplying by the same number. So in that case, it's going to be exponential, and the graph will be a curve, okay? So it might be curved upward, curved downward. It could be curved like that, but either way, it's not going to be line. It's not going to be linear. It's going to be a curve. So again, these are the only two possibilities. Okay, you can read the write-up. I think in most or all cases, you don't need it. The table gives the number of branches on a large tree after the year 2000. What kind of function best models this relationship? All right, I believe for all of these, the first column will be the x values, and the second column will be the y values. Now, like we said in the notes, you don't really need to look at the x values. I'll just do it on this problem just to show you. Notice on the x values, we're adding 2 each time. To go from 2 to 4, it's plus 2. From 4 to 6, it's plus 2. All right, so it's the same thing added each time, and it's going to be like that for all the problems. So you don't have to worry about the x's. But now for the y's, you want to check linear first. Okay, so you can subtract the previous number from the new number. Okay, so I'm going to do 23 minus 16. And that's going to be 7. Okay, so to go from 16 to 23, that's plus 7. Now if I subtract 33 minus 23, that's just 10. So to go from 23 to 33, that's plus 10. I'll do one more. 48 minus 33, that's 15. Okay, so clearly we're not adding the same number each time. So since it's not linear, it has to be exponential. Okay, because there's only two possible answers. Now, if you want to double check, I'll prove to you that it's exponential. We already said it's not linear. So let's see why or how it's exponential. All right, if I did 23 divided by 16, and on the calculator, rounding off, I get 1.44. Okay, and then if I did 33 divided by 23, do that real quick. Rounding off, I get 1.43. You can keep going, But we already established it's exponential. I just wanted to prove it to you. So to go from here to here, it's times 1.44. To go from here to here, it's times 1.43. And I'm sure it'll keep going like that. Okay, notice it's not exactly the same, but it's close enough. But anyhow, you don't have to do this part because once you eliminate linear, it has to be the other answer, which is exponential. All right, so only two possible answers, so we said it's exponential. All right, the table represents a number of burgers sold by a restaurant since it was opened. All right, so here's the table, X's and the Y's. All right, which graph best represents the relationship between time and the number of burgers sold? All right, so they didn't write linear or exponential, but they gave us graphs. So we said before the graph of a line, that's going to be linear. All right, so if it's linear, then it's going to be answer A. And we also said the graph of a curve is exponential. All right, so if the answer, when we do the table, if the answer is exponential, it's going to be answer B. Okay, so instead of writing the words, they gave us the graphs. But anyhow, let's look at the Y values. So I'm going to check for linear first. So I'm going to do 691 minus 353. All right, 11 minus 3 is 8. 8 minus 5 is 3. 6 minus 3 is 3. So to go from here to here, that's going to be plus 338. All right, and then on the next one, 1034 minus 691. Four minus 1 is 3. 13 minus 9 is 4. And 9 minus 6 is 3. So to go from here to here, that's going to be adding 343. All right, like I said, it doesn't have to be exact. So it's looking like linear at this point, but let's make sure with one more step. If I did 1374 minus 1034, that's going to be plus 340. All right, it's close enough that it's the same each time. So to me, that is definitely going to be linear. Okay, if you want to check, if you did this divided by that, it's definitely not going to be close to this divided by that. Okay, so it can't be exponential. So it's definitely linear. It's close enough that we're adding the same number each time. All right, and we said if it's linear, choose the one with a line. All right, for this one, you do need the write-up. It says Enrico deposited $2,000 in the savings account. Each month, he will deposit an additional $25. What kind of function best models the relationship? All right, so it's linear or exponential. There's no table. But what happens in the savings account? So we started with 2,000. And then each month he added 25. So he started with 2,000. And then he did plus 25. You don't need to get the actual number. You just need to know that he did plus 25 each month. All right, so you don't need to get the number. You just need to know plus 25 each time. So if you're adding the same each time, that's definitely going to be linear. Answer A. All right, another one. You need to read the write-up. There's no table. The number of tadpoles in the pond triples each day. Which graph represents the relationship? Okay, it's either linear or exponential for all of these. Let's say something triples each day. What does that look like? Let's say you started with 1 and then it triples. So you basically are going to do times 3. All right, 1 times 3 is 3. Then it triples again. So you're going to do times 3. 3 times 3 is 9. And it triples again. You're going to do times 3. And 9 times 3 is 27. Now, do you need these actual numbers? No, you don't. You just need to know that it's times 3 each time. And we said in the notes, when you multiply or divide by the same number each time, that's going to be exponential. So that's answer B, the curve right there. All right, so we didn't have a problem like this, but remember, if you're adding the same percentage, like if you do plus 20% each time, again, that's going to be exponential.